Hello, friends. Um, I hope everyone is doing great. This is my part three Java self-teaching video. Um, so I'm posting this video for the third time. You remember our last video that is on Java data types and variables. We have seen just introduction overview of variables data types, but today also we'll continue from this topic, Java data types and variables, more in detail and well-organized way, uh, so that you can, code and, try to work on by yourself, especially our purpose in these consecutive videos is just to teach yourself. You can teach Java yourself and get a professional job in Java. So without any delay, let's continue. So today we are gonna continue on the same topic, like Java data types and variables. So yeah, I'm reading data, not data. Some people just call data. It's not right. So data. Say try to read data. It is how to read this data, but many people still say data. I'm not gonna say that. So it is data. So Java data types and variables. Let me highlight this so that you can my favorite with my favorite color, that is green, actually blue. So Java data type and variables. This topic is very basic and very important. In Java, data types specify the type of data that a variable can hold. Okay, let me write. I think it helps you just as a small note. In Java, this needs not be okay, just regular black. Okay, so in Java, data types specify the type of data the type of data that a variable can hold. Variable, actually, a variable can hold. In Java, data types specify the type of data that a variable can hold. As we have discussed last time, variables are a type of box, right? We have seen three types of variables. We seen box, just like box, local variables. I think you remember that the local variables and static variables, those three variables we have seen in our part two self-teaching, Java self-teaching video. So, but variables variables are containers, right? But variables are containers. They are containers. They hold data type. They hold data type. Like, there are labeled boxes, for instance. Check the labeled box, for instance, the labeled boxes that store values, right? In boxes, you put some things and you just package it and send, right? Just that way, we have package for packaging or for storing data, because data types have, the story, the storage, byte size. So they have the size. Depending on that size, the container can hold, many as, there are different data types. So depending on the container, we, we specify the data type to the containers. That's what we do. So that's Java data types and variables are. So there are actually, now we'll see data types first. Okay, let's say this one data types. Let's see data types first. Okay, data types. So we'll see this category. We categorize them, data types. Data types in Java, particularly in Java. We are gonna see particularly in Java, not in other languages like SQL or other data types even. So data types are divided by two types. There are two types. We can say there are two types of data types: primitive data types. So what are these primitive data types? So that we'll see there are, 8 primitive data types. There are 8 of them. Okay. There are 8 data types. There are 8 primitive data types. So what are they? Maybe we can give the points like, okay, let's take this. Okay, there are 8 data types. So what are these 8 data types? For instance, byte. The first one is byte. Call it byte. Byte data type. So these have, as I said, there are, many data types, which all of them have their own size. these have just 1 byte storage. They are containers, right? As I said, they are containers. So this may be, just 1 byte. It is just 1 byte. So we can do some examples. For instance, byte. Let me go to our IntelliJ IDE. Today we are going to code using IntelliJ instead of Eclipse. So we will use interchangeably because, this is also my favorite. So now let's create a project so that we can code here. Var, maybe var. It's just data type. Okay, we're creating this project. Let's say new window. Okay, now we have main class here so that we can practice. Okay, this is break sign. You don't need the break sign. Okay. Okay, we don't need these 2 lines. Okay, you see okay, we need public class main. We only created what? Just main class, even no package. It takes default, default package and default class. The default class here is main class. So I'll give you some examples here. It's possible to give you just here in main class. Here in main class, we have been discussing about byte, right? For instance, let's see with variable. Let's code byte b is equal to, it is only 1 byte, we say, right? 100, for instance. Is it? Byte b is equal to 100. Or you can say, system or is out. Here, if I write b, b is just the name of the variable. As we have been discussing yesterday in our first video in part 1, this is just a reference. This is the value, and this is a container, right? So byte, let's say x. Why do we say just? We can say x and change this to x to print. Let's print this. Run. You see, it's printed here. In the console, it's 100. What about, so this is very small integers. It holds small integers. Byte holds small integers. For instance, how many? Let me add one more 0 here. You see, immediately it throws an error. If I run, it's not gonna run. It cannot hold the size of, you see here, incompatible types, possible logic conversation from into byte. Or here, you see, it says incompatible types. It's not compatible. It's incompatible type. So its ability is just 100. What if we say 150? Let's see. Still, this byte container cannot hold the value 150. What about 120? Let's say 120. Oh, it can hold. You see? It can run now. Let's run. You see, now it's printing 120. You see here? But less 125, say 125. Or it has no error, right? No red here, 125. It also, okay, 126 possible. Let's say 130. You see, it's not gonna hold. This byte is just one byte, you know, 1 byte. This is 1 byte. So 1 byte integer, it holds 127. What about 127? It holds 127. What about 128? Oh, it doesn't. So the limitation is, the size is x 127. It holds only the value of integer 127. What if you make this negative, also negative? It holds negative 127. Even 128, negative 128. Okay. What about negative 150? It doesn't. Okay, 129. No, 128. Yeah. Yeah, this means, what does this mean? We can say, byte is just 1 byte, and it holds from, so we can say the size holds the value from negative 128 positive 127. What we've seen, right? Okay, let me make this positive. It's error, but 127 is okay. See, no error, no red. It prints 127. Okay, you see here, it prints. This is the example of byte data type. They have all their own size to store data. It is the storage, memory, storage. Storage is the main thing in Java program. So you have to learn a lot about storage, memory later on, and many other things. Okay, now let's move to the second type. Okay, so that let's comment this so that we can type. Okay, so that I can give you another example. Okay, now let's move to our note. Okay, here you see byte, just 1 byte. It has the size of 1 byte, but the value holds from negative 128 to positive 127. That is what we've seen, right? This is a good example. I was giving you coding, right? Just practice this. It's very good. Try to master this. This is a small integer. It's a very small integer. And, the second is short data type. We're going to see 8 of them, primitive data types. Short. Okay, types. Okay, short data type. Okay, short data type. This is short. It has 2 bytes. 2 bytes. It's it has the size of memory 2 bytes. The container the container has 2 bytes size. So it can hold, greater than byte, greater than this, right? Because this is only 1 byte, but this is 2 bytes, right? Short is 2 bytes. So, for instance, we can see. Let me give you an example. Let's see how much it can hold. Let's go to our IntelliJ IDE. Here, let me give you an example about. So we are working on short, right? Short. It's not the default. The default is 0 actually. Let's say short x is equal to, say, 32,000. Okay. Okay. And now S out. When you say S out, you can print here X. Bring X to print. Okay, let's print. Okay, you see it prints 32,000. So it has 32,000 size. It stores. It be able to store. The size of 32,000. But here you see 127 only, right? So what about 32,500? So let's see if it exceeds 30,500. Yeah. And 32,900. Let's see. You see, it's not holding. You see the error? It's red. Yeah. Okay. Let's say 32,800. It doesn't hold that. Short doesn't hold 30,800. Let's say 32,700. Yeah, it holds 700. 30,700. And also, let me 32,750. Yeah, it holds 32,750. And let's say 80. Oh, it's not holding. And 75. Oh, it's not holding. 74. Not holding. 73. 773. Not holding. 2. So not holding. So 2,770. Not holding. 700. 69. It's not holding. 769. No. 68. No. Okay, 60, yes. Yes. 60, yes. Okay, 65. Yes. 66. Yes. 67. Yes. 68. No. 67 is the maximum, you see? 32,767 is the maximum. But if you make it 68, it's error. It's not gonna print, right? Let's print, please. You see error? Incompatible types, possible lossy conversation. Java, incompatible types. So it's not, it's error. But just -1, that is 67. See, when you do that, you can run this code. You see here, that 1,000, or x is equal to, let me say x is equal to, yeah, okay, okay, let me say to print just in a way, yeah, this way is good to print, okay? Okay, now let me print. This is just, simple, not good way to print. Let me print, okay, run. You see here, x is equal to 30,767. Okay, let's make it the same negative. Yeah, 68 on negative. Yeah, 9, no, 8 negative. So what does this mean? What does this mean? When it is positive, okay, just take negative, then 60, that's 67. Here, 7, right? But when it is negative, you can add one more when it's negative, just 8. Not 9. If you do 9, it's not accepting. Okay, just one more. Okay, so what does this mean? Short, okay, short data type holds the size from, not the size, holds the value from negative 32,768 to 32,767. You see? Okay, let me just copy this. Control C. Let's copy and let me put it in our note. Okay, in our note. Here short. Okay, let me put here for your note. You don't need this here. Comment. You don't need this comment. Okay, this is the third data type. If we go like this, all of 8, it's gonna take a longer time, right? But it is good practice for you. You are practicing it and you can grasp it this way, but it is time consuming. Doesn't matter. Int, the main thing is you're learning. Int is just integer. It's integer type, but int, call it int, integer. We'll see what the difference between integer and int actually later on. Okay, int is also primitive data types. Int has 4 bytes size. It holds 4 bytes. So what do we mean? It may hold int, maybe it's 4. It's default for integer. This is default for integer. As you see in short is larger than byte, but int is larger than short. Int is larger than short because it has 4 bytes For instance, let's go to our coding and check how it works. Okay, let me comment here so that this code may not affect us. Let me comment it here. You see, all the error is gone now. Okay, let's do one example for int. Okay, int the same x, just so that you can understand. For int, maybe let's say 100,000. 30. Okay, it holds 100,000. That was 32,000, right? 32,767, the short. This is unique, 100,000. That's larger by far, right? Okay, what if we add one more zero? Yeah. 100, 1, 2, 3, 4, 5, 6 million. You see, it holds million. Okay. But let's add another zero. Let's add another million if it holds billion. Yeah. Okay. Now 90 billion, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 billion. Okay, let me make it 2 billion. Okay, it holds. Let me add 3 billion. No. See, billions, but not 3 billion. What if we say here 99? Doesn't hold. You see? What about 50? No. 20. Doesn't hold. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. What about 10? Doesn't hold. Just 2 billion. Let's say add one more zero. 1, 2, 3, 4, 5, 6, 7, 8. You can still add one more zero, but not 3 billion, but 2 billion. You know, it holds 2 billion. What about negative 2 billion? Negative is okay. 2 billion 1. No, maybe it's okay. What about 2? Yes, okay. 5. Okay. Okay, just let's estimate 2 billion, not 3 billion, less than 3 billion. Negative 2 billion to positive 2 billion. Yeah, we can say, you see here, 1, 2, 3, 4, 5, 6, 7, 8. We need 1 0 here. But if you add one more, no, you can't. Okay. So let's say positive. From negative 2 billion to positive 2 billion. Billions. 2 billion, not less than 3 billion. It holds that value. You know, we can say int holds int holds from negative 2 billion. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. To positive 2 billion. 1, 2, 3, 4, 5, 6, 7. Add 0. Okay. Int has the capacity of 2 billion, negative 2 billion to positive 2 billion. You see the capacity to hold this this container. Int container holds 2 billion because it is 4 bytes, right? It's 4 bytes. So let me just copy this and go to our node so that for you remembering, you can remember easily right here if I put like this, Okay, number 4, we still are 5 to go. Long is another. Okay, let me use long. How many bytes long has? 8 bytes. You see twice? 8 bytes. Okay, 1 byte, 2 byte, 4 byte, and 8 bytes. It has 8 bytes. You see, long has 8 bytes. Long has 8 bytes. So that it is trillion or how much? It must be very much. Let's go to our code just to try this code. Okay, let's give practice. S out means x is equal to, or you can say like this. Yeah. Now let's print just to see this int value, 2 billion. You see x is equal to, instead of this sign, just let's say is equal to. Okay, let me print now. Okay, x is equal to 2 billion. You see, x is equal to 2 billion. This is the value for int. Let me comment so that it may not affect our next coding. And this is the way how do we comment. When you comment, this code is not gonna get included. You cannot, you can run the next, and you cannot run this because you have already locked it, commented it. Okay, now let's go to the pores, long bytes. So for long bytes, already we are, I say it has 8 bytes. And same way, long x is equal to maybe how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, not 0. Okay. What about L? Capital L. Any amount, if you put, you have to put L for long. It should be differentiated. So this is trillions. I hope more than trillion. Okay. Now it's showing us error. So it's not accepting this 0, even this 0. Okay, now let's, x is equal to 1, 2, 3. That's okay. 4, okay. 5, okay. 6, okay. 7, 8, 9, 0. That's okay. Let's see. Yeah. What if another is 0? Is that okay? No. So this is okay. Oh, it's not okay. It's red. See? Let me minimize 1, 0. Okay, but if if you add another 0 with L, you see, it accepts. But without, if you are not putting L, but you have to put capital letter L to make use of different 0. Okay, without L, you see, it's not accepting this amount. This amount. Okay, let's more and put L. Right, L. it accepts any amount, you know, because it is 8, right? Let me write some and L. You cannot, I cannot name it, this number, right? It's not a billion, not trillion, no quadrillion, quintillion, something like that, right? Okay, go 0, 0 again and add RL. It's not accepting this. How many numbers? 1, 2, 3, 4, 5, 6. Oh, it's not accepting this. Okay, let me minus 1, 0. Okay, yeah, only 1, 0, minus 1, 0. But you have to write L at the end. Long, that is long, okay? So how many numbers? How many digits? How many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 digits. So you can say this maybe, 19 digits. It holds, okay, holds the value 19 digits, right? 19 digits with L. So it has 8 bytes. Okay, let me copy this, Control C, and come to the note, come to your note, and add here. Okay, 19 digits. Now, what is the fifth one? I've already shown you the example. Okay, let me print this. Okay, go to this and just let me print this. Long X is equal to this. So to print, you have to go S out, and double click here. Then here, quotation, X is equal to, and here plus or concatenate. So now it's gonna print. Okay, you can print from here too. You see, from here or even from here. Okay, it's IntelliJ. Yeah, you see here, X is equal to this number, but L is here. Don't forget, L is here. You see here, it's L here, but when printing, you don't see L. It's not printing L at the end. It's more than trillion, quadrillions, maybe even more than that. It's the power of 19. It's to the power of 19. Okay, let me comment this code so that I can show you the next code. Okay, now let's go to our notebook. As we are using Word as our note. So the other one is float. So I think we seen last time, right? Float. It has only 4 bytes. Because this is, the precision it works with the precision if you are aware of mathematics precision of, you know, um, in float, for instance, point. Okay, let me show you an example. I think it is good to learn with example. Now, float x is equal to float x is equal to 12.34. Okay, why is error here? You have to write f here. You have to write f. What if you don't write f? It doesn't. You see, the compiler doesn't understand this is float. So you have to write f. Now float x is equal to 12.34 f. Right. This is how you write. This is decimal numbers with f. Decimal numbers with f. Numbers with f, right? The other was with L, but this is with f. Control C. But before we go to, let's print this code float. No, you don't need Y, but S out. Okay. Now here. Okay. Okay, now let's run this code. You see, X, but Y, let me say is equal to X, this point. The compiler is adding things. Okay. Now we will see X is equal to now. Okay, you see here, X is equal to 12.34. 1, 2, 3, 4. This is decimal point with F. Decimal point with F. Okay, now let's go to our note and we can note this. And we have the next, I've shown you examples for all of, now the other is double. Double. How many bytes do you think the double is greater than float? It's 8 bytes. It has 8 bytes decimal place. It has 8 bytes decimal place. Double. But double is, you can. Okay, let me show you with coding example. That will be good. Let me comment this code like this, and now let me show you this double example. Double. It's default for decimals. It's also default for decimal. Double t is equal to, for instance, 1, 2, 3 dot 1, 4, 5, 6. See here, 4, 5, 6. You see the difference with, what about if I try this? What about this? Yeah, you can do the lower, but these are 8 bytes. You can add any precision place, 3, or here 4. You see, you can add, but in float, you cannot do that in float. Both are decimal numbers with F, and this is a decimal number with D, can say. But let me add some more here. 5, 6, 7, 8. Okay. Let me, especially here, before the point, because it is 8, you see, now after how many decimal places? Any number of, this is because it has 8 bytes. So maybe here, you can do whatever numbers. It's not showing error, no error at all. But you here you can, okay. You see? But you can put D at the end. Okay. It's very high, very high. I cannot even tell, but just for double D is equal to, just simply let's differentiate from your float. 0.456. And let's print this as out and here x is equal to, oh, it's D, so, and also here D plus D. Then you can print this. Okay, let's print. You see, D is equal to 123.456. So you can any number, it may reach here. You can't reach, it's long, 8 bytes. So what you can say is decimal numbers is default to decimals. Even it is default. By default, it accepts. We can say default decimal. Okay, default for decimal. Okay, default for decimals. I've already shown 2 more, right? From primitive data types, 2 more. And the other is char character. You can say character, ABC, it has only 2 bytes size. It has 2 bytes, char or character. The default is Unicode, Unicode. The default is not only character like that, but Unicode is how you do Unicode. Okay, Unicode is and any number you see U or any zeros. It's Unicode, just any Unicode characters. The default is, character, this Unicode, we call it Unicode. Unicode. Okay, it's Unicode. So I think let's see coding. It's only 2 bytes. Let me comment this code. Mhm. Comment this code. Okay. So character is, it's different from string. A string is a name or any writing, right? Any writing. But character is just A, B, C, D, E, F. These are, for instance, char x is equal to, you say, A. Okay. Char C, let's see. Char C is equal to, actually, for a string, you have to double quotes, but for characters, you have single quotes. You see? Or any character. Z, yeah, any character. So char C is equal to Z. See, in a single quote. So let's run this out. Oh, small s out. So here, okay. Now let's see. Let's run this code. Z is equal to, you can say is equal to just okay, C is equal to Z. This is how char, that's why it's 2 bytes, because it has Unicode. That's why. And the last but not the least, is Boolean. It's very much, we use it very much, this Boolean. Okay, let's go to our our code. Number 8 is Boolean. Boolean is also primitive, but how many? 1 byte, 1 bit, even not byte, but just 1 bit. So the default value is false. The default value is false. This data, this Boolean helps only to store true or false. If you are storing false or storing true, then the Boolean container is just Boolean, that is true or false values. The default value is false. It stores true or false value, yes or no, in database, something like that. So these are the primitive data types, okay? These are the primitive data types. So let me give you one example, coding example, and Boolean. So Boolean B is equal to, you see it true. Boolean is equal to true, and S out just B. B is true. Okay, let's run. B is true. B is true. B is true. What about here? Say false. Let me run. B is false. B, this is the name of variable from the, you remember from your last time, from your second part 2 video. So this is the Boolean. Let me comment this code too. Actually, we are not gonna run now for today. As more than enough primitive data types. We have seen, coding each one of them, 8 of primitive data types. But there are other data types, primitive data types. We have, maximum, short maximum. We have seen the maximum value, the int maximum value, the long maximum value, and also the float maximum value, double. We have seen just, and char, what char is, what Boolean, true or false. So we have seen all these. But now, I think the second non-primitive or reference data types we'll see in our fourth part. For today, I don't want to load you more than you can handle. So this is enough just to teach yourself about data types. This is the first data types. These are primitive data types. They are 8, and you can, practice and study them and practice them, how to manipulate them. Okay. Thank you very much for our today's class. It has been wonderful. Thank you.